Merhaba sayın hocalarım, sayın katılımcılar. Bugünkü toplantımıza, çağrılı konuşmacımıza hoş geldiniz. Kusura bakmayın heyecanlıyım. Murat beni böyle görünce hemen beni görevlendirdi. Hiç de mantıklı bir hareket değil ama yapacak bir şey yok. Bugünkü konuşmacımız John de Jong. Kendisini 2014'ten de EPOD Kongresi'nden de tanıyoruz. Kendisi bugün Rush Modeling in Language Testing ile ilgili sunumunu yapacak. Ben hemen kendisini kısaca tanıtayım. Tanıtım İngilizce olacak, kendi şeyiyle beraber. Ladies and gentlemen, welcome to this session. I will introduce the John de Jong from the Language Testing Service. John de Jong is an emeritus professor in language testing at the University of Amsterdam and runs a consultancy business in language testing services to provide consultancy on language testing and educational measurement. Among his clients, language testing companies, the national ministries of education, the World Bank, the OECD, and the European Union. At Pearson 2006 and 2016, he developed the Pearson Test of English of Academic and the Global Scale of English and acted as a program director for developing the framework for PISA 2015, 2018, and for the PISA for development. John has 47 years of experience in language testing, and he graduated in general linguistics, French and English languages from Leiden University and obtained his PhD in educational measurement from the Twente University. And he has specialized in empirical scaling and the development of the internationally standardized reporting scales of the language proficiency. So he was involved in developing the common European framework for languages. Ladies and gentlemen, please welcome John de Jong.
Thank you very much for this introduction. I'm very happy to see that my PhD supervisor is also here in the audience, so I hope he will not see any faults in my presentation. Okay, so I was going to talk about RESH modeling in language testing. It has been a very controversial subject in the beginning. People said you can't have language testing in a single dimension. That's impossible because there's so many different things in language. There's grammar, there's vocabulary, there's speaking, there's listening, there's writing. So, is it possible? Well, we will look into this today. So first I want to share with you the beautiful logo. It's not working. Oh. It's not working. It's just only doing this screen.
Oh, okay.
It's not doing the other screen.
Let me see. Let me check. Okay. Sorry about that. Okay.
It was only changing this screen, not that screen.
Yeah. Bunu değiştiremiyoruz. Kısa yol şu F5 miydi bunun?
Try. Yeah. Okay. So this is the beautiful logo of this university. I think it's a very fantastic logo. You can have all kind of thoughts with this. It's eternal. It is returning on itself. It's beautiful, really beautiful. So I stumbled upon this and I thought I want to show it. Okay, but my talk is about language testing, and language testing is in fact two words. We have language and testing. And language is about linguistics. And we need to define what it is that we want to measure. We need a structural model of what language is. So, a very early paper that I wrote was in 1983, and it was called Focusing In on a Latent Trait. And the data that I used were 575 Dutch students of English. They were 18-year-old, they were university bound. But I also had 30 English first language speakers who were comparable in age and background. And I had a test of listening comprehension of English, 59 items, 2 options, multiple choice. So let me show you a theoretical model of a test which has, in fact, 2 abilities that it is addressing. Some items address specifically ability A, and other items specifically address ability B. If you put these 2 into a test, then your trait will be some kind of average between the overall items that are in the test. But that is not, of course, maybe the ability that you want to measure. Say that you want to measure ability A. Well, then you have to get rid of all those items which are specific for ability B and get them out of your test. And so if you delete these items, then your trait will come closer to the ability that you want to measure. So that was the theoretical idea behind the experiment that I was conducting. Now here we have this 59 items of English listening comprehension, and we see that, so we have a cutoff of 0.80 for speakers of English. If they score below 0.80, then those items are in fact too difficult for people who do know English, because English speakers know English. Yeah? But we also have a measure of fit, which is including in the Rush model. So we see that according to Wright's, Benjamin Wright, he said 2.21. If you are above 2.21, then your item doesn't fit. So we have 35 items among the 59 which are easy enough for English speakers and which also fit in the test. But we also have 9 items which are too difficult for English speakers and which don't seem to fit in the test. Well, that's fine. We get rid of those items. Those are the wrong ability. Yeah? But we also have 8 items which are easy enough for English speakers, but which are not fitting in the test. But of course, this test is not the right test. It still has those 9 items which are too difficult for English speakers. And it has, furthermore, it has 7 items which are also too difficult, but which seem to fit. So we have a total of 7 plus 9 is 18 items which are too difficult for native speakers. So if we now get rid of those 9 items, we move the 9 items, then some of the 8 items, which are easy enough for English speakers, will show to fit in the test. And those items which do fit in the test, but are too difficult, they should move up and get a higher fit measure. Does that work? Yes, it does. We now have 36 items. And 3 new items which do not fit and which are too difficult. So they came from the bottom and they moved up in fit. we have 1 item less there, and we have 3 items less there. Now, going on and on, we finally get 42 items which fit in the test and which are shown to be easily tackled by native speakers. Now, that's fine. We have 1 more item in the 2 spare boxes, but let's just go ahead and see what this is. So we have only 1 more item there and only 1 more item there. But we have 0 items which pass both criteria. Now let's look at this test. So we have here all 59 items. The dotted line is the native speaker mean ability, mean score. And we have 6 ability groups of the Dutch students, 1, 2, 3, 4, 5, 6, and they show a growing curve. But if we look at the 40 best items that we just selected, then we see that the native speakers are much higher, and that among the Dutch students we have more discrimination. This line is steeper. Okay. Oh, okay. So you want a microphone? Okay. Okay. Sorry, I move about too much. So, okay. But if we look at the 19 items which we deleted, we can see that the native speakers are no better on those items than the Dutch students. They score way below the top Dutch students. So that is a test, those 19 items, that is not measuring English language ability. It's measuring something else. Maybe general ability or something else, but it's not English. So that is now my model for making English language tests. I need to check whether native speakers who are born in a country can speak the language. Now here's then my general model of language development. If we know that somebody who is born and at 0, they have no ability, they have no language ability, and they have no general cognition. But if they are 1 year old, they grow, and they have some language ability, and they also have some general cognition. And as they go and grow and grow, we will have, of course, in normal situations, a perfect correlation between general cognition and language ability, if all is well. Yeah? Now we have a language learner who is learning another language. So they start and they grow in general cognition, but they need to speed up to acquire that other language. And so then they go and grow, and we hope they move asymptotically towards the general development which we see in native speakers. And here's another learner who started a little earlier, but now we're going to measure these people. And if we measure among the group of language learners, so we make a test among the language learners, we risk to measure 2 things: the target language, but also their general cognition. 16-year-olds will have less general cognition than 18-year-olds. And if we measure between these 2 groups of language learners, so between 16-year-olds and 18-year-olds learning a language, we might only measure general cognition. So what do we need to measure? We need to measure in how far the language learners are different from the speakers who have known the language all along. We call them often native speakers, but they are in English, they are English-speaking people, yeah? Okay. So that is what we need to do. We need to include the appropriate group of native speakers in our tests to check whether the test is indeed measuring what we want to measure. That's what I showed in the focusing in on a latent trait. Now, here's the Pearson test of English, which was mentioned that I was the main developer of. So you see English speakers who have, this is on a Z score, which means the Z is the difference from the average. So we see that all the red circles, almost all the red circles, are above the mean. Yeah? They're in the top half. Whereas the non-English speakers, they are all over the place. And it doesn't matter what age they are. At any age, there's more red dots in the top than in the bottom. So this is a good proof of that this test is indeed measuring English. I did the same with a test of Dutch, which I developed for the Dutch Ministry of Immigration. They wanted to test people who come into the country whether they know enough Dutch to hang around. Well, you see here again, the Dutch speakers are in the top and the Dutch language learners are all over the place. And here's a Spanish test, which we developed for the US Army. And again, you see the Spanish speakers are in the top, and the non-Spanish speakers are all over the place. So this is the model that I use when I want to measure language ability. And there's many language tests in the world which do not have this proof that they are indeed measuring the language. Often the tests of English that we see around, they are too difficult for the native speakers even. So we can also show that in a graph. We see the cumulative curves for non-Spanish, and they are growing from 0 to the top, and they have an overall score, and this is what we see normally. But then the native speakers, there's hardly any native speakers here. They come at the top scores. So that's another way of picturing this right form of development. All these results are in fact due to AI. AI is currently such a craze, such a modern word, but we used AI in language testing from 1996 for testing speaking. We have speaking models that test automatically, score students how they speak. We have writing models. Thomas Landauer has developed the latent semantic analysis, and that is used, and it is in fact AI, because it is based on models of language, and then the speakers are compared to the model. And these AI scoring algorithms, we see that we have on the vertical axis we have the machine scores, which are generated by machine, and on the horizontal axis we have the human scores. So humans listen to the students and they score them, and we get a perfect correlation between the two measures. So to show you what you can do with all this, we have here an experiment with a test of Dutch listening comprehension, and we used it on native speakers of 18-year-old, native speakers of 16-year-old, Dutch speakers of 18-year-old, Swedish speakers of 18-year-old, Norwegians of 17, and etc. You can read all the different groups that were in there. Now we can see what the mean score of the native English 18-year-olds was. And we also have the error of the mean, and we have 3 standard deviations. So that's the total distribution of these native speaker groups. Now we want to see how the other groups fared on this test. And we see that the native speakers of English at 16, they score slightly lower, and the Dutch students even lower, and so on. Yeah? Now we have a perfect growth curve between these groups. But we also have data on the TOEFL listening comprehension scores. ETS used in the past to publish the data on different language groups, but they do no longer do that anymore. They stopped in about 87 or 88. But before that, they did show the different scores. So we have a score from 49 to 69 here, and the world mean on the TOEFL was about 52. We can compare that 52 because the native speakers of English on the TOEFL had 63. And so this is a form of test equating that we're seeing here. And Dutch students of 18, they had a score of 61. And so we have the Swedes and the Norwegians and the Hungarians, and we see that there is a perfect match between the TOEFL test of English and this Dutch listening test that we developed at CITO. Yeah? So there's nice comparison and a nice way of equating those two tests. Conclusions: using the Rush model to evaluate item quality has helped to improve test validity. But using the Rush model also provides consistency in measurements across populations. Now, I started saying that language testing is 2 words, so let's now look at testing, psychometrics. We need to define how to determine differences, and we need a measurement model. I've been using the measurement model, but now we will go into more detail about the measurement model. Anybody who's acquainted with the Rush model knows that this is the standard curve of ability growth. And in fact, it portrays the difference between ability and difficulty of a task. And so if the difference is 0, they have 50% chance, and if it grows, then the chance becomes bigger. So here's the curve again, but let's look at what the curve is. Is it really a very single curve? If we look at this, it's a string of wool, and within the string of wool there are, of course, separate strings that have different directions. Yeah? So any test that will also have items which are a kind of shaky or whatever, yeah? But that still doesn't mean that you cannot use the Rush model. Here is the item response curves for a single item from PISA used on different countries, but there is one country for which this item was not appropriate. And you can easily see that is the yellow one. yeah, all the other curves fall more or less together. And that is the same as the string of wool that I showed you. We can see it is all kind of strings in all kind of directions. It's like the string of wool, yeah? When we look at that very tiny piece of the curve that I showed you with the magnifying glass, we are in fact doing a restriction of range. And we know from correlation theory that restriction of range can create havoc, because the correlation of these dots is 0.9, but if I restrict the range, I can find a piece where the correlation is only 0.3. Yeah? So that's perfectly normal, and that happens also in the Rush model. So let's now go to the issue of dimensionality. Is language proficiency multidimensional or unidimensional? And we can go even further. Is school learning multidimensional or unidimensional? It all depends on how we approach these facts, these methods. The principle of unidimensionality by William Stout was shown that in fact we need to talk not about unidimensionality, but about essential unidimensionality. So whether a group, where a test is essentially measuring a single dimension. It can of course also apply to some other things, but essentially it is one dimension. This is a lot of text. So let me show you here. This is a graph of the Pearson test of English academic. And you see on the left-hand side, you see 21 different item types. And these item types deal with different skills. So we have, I'm afraid that the characters a bit mixed up because of the Turkish program here. So we see reception, this column, production, oral, and written. And here we see grammar, vocabulary, structure, pronunciation, fluency, intonation, and spelling. And so when this is gray, it means that part is addressing this particular skill or part of skill. And then we have on the final panel, we have the type of items. And so we have different items, multiple choice items, gap filling items, hotspots, drag and drop, semi-open, and open. So different item types, different skills, all into the same test. Now, is that going to be a problem for the Rush model? First of all, we can interpret this as a multi-trait, multi-method approach. We have different traits and different methods. And we all want to measure English, and within English, we want to report also on speaking, listening, because people like that. If I just report a total score, people will say, yeah, but how about the listening of these students? So they want partial scores. Now here's a first shot at the quality of the test. We divided odd items and even items in the test, and we correlated the odd and even items and how students fared on the odd and even items. And that is showing that it doesn't matter what students get. whether they get odd or even items, they all score in comparable way. We also can analyze the data per skill with a unidimensional Rasch model and with a multidimensional Rasch model. And you can see that it doesn't make much difference whether we analyze the test and estimate the difficulty of the items with the unidimensional or the multidimensional Rasch model. It's about the same. Even if we go skill by skill. So here in the left hand we have writing and reading. Very high correlation between those two skills. We have speaking and listening, very high correlation. So it doesn't really matter. Then Mark Reckes came along, and he was on our advisory board, and Mark said, if you are scoring the test with the unidimensional Rasch model, and you report an overall score, then in fact you are not allowed to also score for reading, listening, speaking, and writing, because you have a unidimensional trait. And then we said, yes, but the people want it. And for each individual, it might not be the same. So then Mark did a cluster analysis, and look what he found. He found that there were indeed different clusters of items. And one cluster, the top cluster, the turquoise, is word recognition and pronunciation. And then green is writing. And red is reading comprehension. And yellow, spelling and phonetic coding. And blue is oral production. And magenta was listening and oral production. So he did find, with cluster analysis, that there are some different traits which are triggered by particular items. So although the test has been shown to fit the unidimensional Rasch model, it still has information and it's still justifiable to report on subscores. And let's look then why this is important. Here we see the score, the total scores of a number of students from different countries and their scores on reading, writing, listening, and speaking. And we see a number of patterns like Taiwan, where the reading is the top, writing is a little less, and listening and speaking are even less. But we see that pattern also for France, for China. But there's also a different pattern where the reading and writing are lowest and the speaking and listening are highest. And that is for Indian students. Well, if you know India, then you know that a lot of Indian speakers, they speak English. Yeah? It's a very common language in India. So no wonder that for the speaking and listening skills, they are above what you would expect given their reading and writing scores. So it does make sense to report subscores, because for different countries, the students have different profiles. Even if the overall test is shown to fit the unidimensional Rasch model. Now we come, I said, do we need to think of language as unidimensional or multidimensional? Now we come to school subjects. Our school subjects, overall schooling, is that single dimension or multi-dimension? Now, in PISA, reading literacy is defined as using, reflecting, and engaging with written text in order to achieve one's goals, to develop one's knowledge and potential, and to participate in society. Very noble, yeah? That's but note, the definition doesn't contain any limitation on the content matter dealt with in the text. There's no limitation on the content. So the text can be very complicated, mathematical, scientific, whatever, or simple kitchen talk. Now, mathematical literacy is a little more complicated. It's an individual's capacity to formulate, employ, and interpret mathematics in a variety of contexts. It includes reasoning mathematically and using mathematical concepts, procedures, facts, and tools to describe, explain, and predict phenomena. It assists individuals to recognize the role that mathematics plays in the world and to make well-founded judgments and decisions needed by constructive, engaged, and reflective citizens. Okay. But the definition contains no limitation to the language use in the mathematics task. So a mathematics task is often a lot of language explaining what the student has to do, but if the language is difficult, then the math becomes difficult. And we have scientific literacy, is the ability to engage with science-related issues and with the ideas of science as a reflective citizen. A scientifically literate person, therefore, is willing to engage in reasoned discourse about science and technology, which requires competencies to explain phenomena scientifically. Explain, isn't that language? Understand scientific inquiry, sounds like language to me. Interpret scientific evidence. It is also language. So that the definition contains no limitation on the computations required. So in science, they also use computation, mathematical computations. And it says no limits on the language that is used. So here's the mathematics item. A school class wants to rent a coach for an excursion, and 3 companies are contracted for information about prices. Company A charges, and you can read. Yeah, that's a lot of language, isn't it? And to understand the mathematics problem, you must understand all this language. The Flash-Kincaid level of this text is 12.5, and the Lexile measure is 1390. That's pretty high. This is above the range of 1210 to 1380, which represents the demand of text that shouldn't be reading by grade 12. So it is above grade 12. And this is for 15-year-olds all over the world. Yeah? Now a reading item. Do our teeth become cleaner and cleaner the longer and harder we brush them? Well, you can read it. And then we look at the Flash-Kincaid. It's a grade level 2. And a Lexile measure of 810. So the reading text is much easier from a linguistic point of view than the science item or the math item. Furthermore, we have quite high correlations between the different PISA scales. We have a PISA scale for reading, science, and mathematics, and all the correlations are around 0.8. Yeah, little below, little above. And the final reliability of these scales is around 0.9. Now, you can calculate what that means. Yeah. The correlation between those scales is an underestimate because of the not perfect reliability of the scales. So in fact, the maximum correlation, given the reliability, would be that. And if we correct for attenuation, then the correlations are even higher. So conclusion, from a psychometric point of view, as from a content point of view, it makes sense to abandon the wish to measure subject areas separately. This doesn't really have any meaning. We are measuring overall cognitive ability of students, entering via text, via mathematics problems, via scientific problems, but they all point in the same direction. And it may be more cost effective if PISA would drop the wish to score all the time 3 different areas. Thanks, and questions.
Well, thank you for this fruitful presentation. It's now we're getting old, right? So the language testing and then the rush modeling, and then it's really engaged. So, and then thank you for Mr. De Jong for this beautiful presentation. And I would like to give him some presents from us. Hopefully you can join it. And then please welcome Mrs. Neşe Güler, our professor. So she will introduce you the presentations and some gifts.
I'm so proud and nice to meet you.
Okay.
So happy.
Yeah.
Thank you so much.
Thank you. Beautiful.
We are so happy to
It's
be
locked.
with you.
It's locked.
Yeah, how can I open? Okay, I got it. I'm more excited.
Oh, beautiful. Look.
Also
It's a perfect.
Yeah.
Perfect for the Turkish coffee.
Yeah.
And your espresso, obviously.
Yeah, I love espresso. But where's the symbol of Anadolu?
Right. Yep.
Thank you very
Thank
much.
you.
Thank you.
You're welcome.
Thank you. Thank you.
Mr. De Jong, I'm a rookie for the presentation, so sorry about that. So we need to get your questions if you have any. Sorularınız varsa alacağız ve ben translate etmeye çalışacağım. Buyurun. Yeah, let's do that.
I can use this microphone.
Thank you, Professor, for all this information and for sharing this with us. I was looking at the correlation between different subject and reading in PISA. I have one question with 2 parts. First, PISA is designed for graduation readiness for a student that, with assumption that they have fluency reading, fully comprehension understanding, and it's a skilled base. But when we go to the primary level and the middle schools, the differences between different subjects is hugely significant. I've been observing class or different student performance attainment across external benchmark and internal assessment for the past 8 years, and I can see that it is like, for some reason, at the grade of 9, it's become consistent. Like, as you mentioned, from grade 9 onward, it become consistent that this is the cognitive level of that student, and whatever he study, he has this stream. But before that, the differences between different topics is high, and it's very significant, and it's affected a lot by the level of comprehension and understanding they have and fluency reading. So do you have any data for the lower age?
So the PISA addresses 15-year-olds.
Yeah, it's a skill
So
based.
students who are about to leave school and who
Exactly.
are going to university or to work. There is also a program which is called PIRLS, P-I-R-L-S, and that is for younger students.
Yeah, but PIRLS is only reading.
It's only reading, yeah.
Yeah.
Yeah.
But in terms of PISA, you can see the difference between math and science.
Yeah, no, they should, but maybe you should write to the OECD and ask them to also make tests for younger kids about math and science. But it's not done currently. No, no.
Thank
Sorry.
you.
Any questions? Okay. Soru yok herhalde.
Everything was clear.
Yeah, I think everything is clear. And thank you again for joining us for this session. And thank you for Professor De Jong for this very informative presentation. And we will be joining for lunch. And
lovely.
And yeah, please prepare yourselves, and then we'll be talking at the lunch. Thank you.
Thank you.